Oh my goodness! Crinkle, 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 smash, bang. Hello everybody, welcome back to the channel. Alright, what are we doing here? Thank you so much for checking out my content. I really do appreciate it, and I really do enjoy making it. So I kind of had this misconception about the whole XYZ hold position waypoint system stuff. So basically what that means is I'm going to have to reconfigure and rethink this. So when we're sitting in space and we want to hold the position, all we need to do is turn all these body thrusters on, and it's going to have force this way, this way, this way, and this way. And that way we're going to stay in, it's going to try and force us into one small position. Then all we need to do is measure this height, and that should be it. And if we turn these things down low, 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 so they consume a low amount of gas, maybe that is where we need to go. So if I want to move from this XYZ position to this XYZ position, then I would need the system which I have, which is the greater than, less than, blah, blah, blah. But I just kept thinking about it. I haven't tested it, but I just kept thinking about it. I thought, you know, it's just the wrong approach. All I need is one button to turn on the thrusters, and that's it. And they don't need to do greater than or less than. They don't need to read anything. They just need to apply thrusting force. That's it. So instead of saving the position, channel 1, and then because it's already a flip switch, we just gotta go north, south, east, and west. Oh my goodness, cat is just cat. So we don't need this. Yeah, I'm talking to you. I'm talking about you. Cat. He wants to go down the hall and smell the doors. Yeah, he wants to go down the hall and smell the doors. Because on my floor where I'm at, there's like 7 cats. It's crazy. One apartment has 3, the other apartment has 1, and the apartment across the hall has 1. Okay, come here. Come on. So he can just walk down the hall. Yeah, I'm talking about you. What? He can walk down the hall and he stops at all the doors. And he smells the door. And then that's it. Alright, and I'm gonna get your tail out of my nose. Alright, so we've reshaped this. So that way, what are you trying to do? Come here, Ben. If you want to sit in my lap. He's sitting on the mouse. He's smart. He's really smart. Yeah, I know. You're really smart. We had, so when, I suspect when he was in the shelter, they had him in this tiny little space. And it was like its own space. So I suspect what he did was meow at the door quite a bit. You know, which is what cats do. Alright, so that one there is our theoretical position. See how all the thrusters are thrusting? We're staying in a solo position. So that's it. That's basically it. So that's where I was thinking of something totally different. And I just wasn't being practical enough. Sometimes when it comes to these builds, I will eliminate this. You just need to be a little more practical. So that means that those 2 buttons work. Okay, so we've eliminated that button. And then we will save the rocket ship. So now when I go to space, I should now be able to hold my position. Ooh, this is really exciting, which means I can bring my speed almost to 0. So that's the next test. Let's launch to space. Let's see if we can slow down and get our speed to 0. And if we can, then we can start looking at the habitat. Walking around. You know, I mean, we're obviously not going to be walking around because it's like low gravity, but, you know, you get the idea here. So main thrusters, I wonder, I also want to test this. Like, I know we need a lot of speed. but I don't know if they necessarily need to be at as strong. These are at 0.7. We could try 0.6 on this one. And the body thrusters, I want to try like 0.1 for when we're in space. So, now that we've got that configured, main fuel pumps on, secondary fuel pumps are on. Turn the systems on. And then we can just launch, which is button number 1. That's it. Oh, and then we want to turn on nose stability. It's kind of enough. Let's see. I just want to adjust it down, and just to see, you know, like, does it need to be that much? Because the rocket does trim quite well. So maybe we don't need it. Yeah, that might be a bit better. And then our speed, obviously. You know, because this rocket is small, maybe this could be like 0.5. Yeah, you see, that didn't really slow us. Slow this down a lot. But we're consuming way less. By reducing our rocket engine power by 50%, we're consuming way less gas. And I think this is oxygen and this is hydrogen. Hydrogen is 2 to 1. I'm pretty sure that's how that is. I still haven't gotten through that. Right. So this is our distance. Where is this like fully going? What? Yeah, we are slowly. I don't even think we're reaching 6,000 yet. No. That's our speed. So we're a slow rocket right now. There we go. Now we reach 6,000. Yeah, you see we're moving. I can kind of explain this, but I'm still not too sure about that. It makes sense with that. Right? We do have a little bit of a linear speed, and that could be why our rotation on the Y is changing. Our position is changing. Instead of being here, we're moving in that direction slowly. We're moving this way negative. So that explains this. Now, if I turn on the body thrusters, we can try to get that to 0. But it doesn't really matter. We're just wasting it. Now we'll have to compare this, because when I got there, I only had 7,000 oxygen left. Looks like we're going to have potentially a lot more, but we still have 20,000, 30,000 to go, meters to go. Yeah, so someone was saying I can use delta and multiply that by 60, and that should give me my linear speed as well. Because what delta does, but see, delta takes your XYZ. Is it XYZ? I don't know, I think it's just position to position. But I'm gonna have to check that out. But I thought maybe it was XYZ. Perhaps it's position to position. We're going. We are going. Yeah, 23,000. And it looks like I'm probably going to be burning almost the same amount of fuel. Right, we'll eventually get there. Maybe not, maybe a little bit less. Okay, look at our speed now. So now we can trim this back. Now that we have so much speed. Maybe that was a little bit too much. We'll be in space here in 10,000. So we might have enough for this way, like a faster one. Slow down at all. Little bit, not really. Now we're speeding up. So we could cut the engines here. And then cut the nose cone. Did I activate the seat? I did. Still does that. 5 and 6 are still connected together for some reason. Alright, so if I turn on the audio, so like that should be enough to sort of hold us where we are, and then we'll slow down on the velocity here. What I do, I just look at this and slow it down. I'll mark it. Oh yeah, look at that. See, it's trimmed our speed right down to 0. That's awesome. Now we just need to get our height figured out. Pretty close, pretty close. Like we're low atmosphere too. That's not very far along. Alright, so we'll activate height hold. See how. Oh, it bounced me. It bounced me. That was way too much. That was way too much. Damn, I locked it. That was way too much. the idea is just to have a low speed, a slow enough speed on all axes that we can sort of walk around the ship. You know, it doesn't matter that you're traveling, it's still. This is a little concerning. It's still going a little bit too fast for explains it. Almost there. What's going on with these? Yeah, there we go. Let that correct me. Now we are falling back to the earth. So for some reason the height hold isn't working. that is. Look at that. That was able to correct. Nice. I wonder if I could turn this down to like 0.45. Just has to be so sensitive, right? So subtle. That's exactly it. Look at that. That is exactly it. And then the main rocket. Look at that. We've stopped. We're actually... See, now if I can get the height hold working, I might actually have a way of getting this thing stable. Yeah, it'll tip a little bit because I'm applying way too much thrust on the bottom. But I mean, that's not too bad. The thing is, we're just going to keep falling. This isn't too bad. I can walk around here. It's just our velocity, right? So if I turn this down to like... So all it has to do is just pulse. So now we're not even, we're just reading the instruments now. Look at that, we're reading the instruments and they're telling us. So now we have a really low, now I wonder if I turn this to like, 5. Just leave it running. See how it's not enough? Look at that. That's almost too much. Look at that. Now we are slowly accelerating. Ah, it doesn't take much. We can even go with a lower number than that. So it's between 2 and 3. Now we're able to see that. Now we're able to really move around in here. Cool. That's really cool. We've almost done it. Almost come to a complete spot here. Now it's just a matter of, can I get the this to balance out? Can I slow our linear speed down? You know, and I mean, so long as these numbers are small, they're reasonable, and we can deal with it. We don't want the numbers to be too large. Otherwise, we're not going to be able to deal with it. Yeah, and then of course we can be broadcasting our position, our XYZ position, to our ship, so we know how to get here. So now that we sort of know kind of what's going on, we can't really be stationary, but if we try and give ourselves a really low bit of speed here, and we can even slowly ascend. You know, it doesn't matter. We don't have to descend. We can slowly ascend. Ah, and I'll start to slowly ascend now. Yeah. That's too fast. So now we're starting to accelerate. Oh, 6 now. So you see, it's kind of a, you know, it's really, and now this, of course, the 27 linear speed, that's a bit much. I'll have to find a way to try to stop that. So maybe what I need to do now is, on the center here, is try and just be able to pulse these manually. 1, 2, 3, 4, and that might be able to manually slow that down. Maybe that's the thing, right? Because now I've got the nose cone dialed in. I've got the height dialed in. So we have 2 different setups, right? 2 different setups. Maybe the body thrusters need to be turned way down, as you can see. Maybe they need to be like 0.5. This might work. Let's try it out. Why not? Right? The main thrusters need to be 0.3. Great. Yeah. Paper from my printer. Point 0.03 for space, and then we figure 0.05 to launch. That doesn't really matter. And the nose cone, 0.005 for space. I think this is how we figure this stuff out. Now, activating the body thrusters hasn't really changed the linear speed at all. It seems to be quite constant, so that's why I'm thinking if I can manually pulse the center, I'll be able to try to slow it down. Cool, well this is almost a success. Let's see. It is almost a success because I can kind of walk around. The only thing that's kind of preventing me from walking around is this linear speed is a little bit fast. You know, it's 28 meters per second. So, but it's still not bad. Let's see if we can get up here. The doors as well are going to tell us. Oh, I just came up. I can just jump through. Yeah, so this is what I was hoping to do. Now I can walk around here. And then we open up this door and I'll be able to walk out to space. And then come down here. Let's see if the, yeah, so that hasn't trimmed at all. Look how far we travel off before it started. Slowing down a little bit. yeah, it's still playing. Alright. Cool, so one of these, I guess it'll be flat, one of these is going to be the habitat, like for the beds and all that kind of stuff. This one here. Oh, look out for that. Nice. So I've almost got it. As you can see, I've almost got it. Look at that. Oh, this is going to be really cool where we're going with this. I've almost got it. So we just need to trim down that linear speed even just a little bit. If we can get it down here, and I think I know where I messed that up, but if we can try to get that down, that will do it. That will do it. Because we don't need this once we're there and we're stable. I guess we do need it a little bit. It'd be nice to slow this down. That's our X there. It'd be nice to slow that down. See what happens. Nothing, it doesn't change at all. Wow. So that's a constant speed then. That's a constant. So now what I have to do is so I gotta change that. So I can manually pulse. So we'll need one more set of rockets in the body. Alright, let's do that. Slow policy. Let's do that then. One more set of rockets in the middle of the body. And then we could then convert our speed from meters per second to kilometers if that's what we wanted to do. Or miles. We could do both. We could have a button that tells us either or. Let's see. So on the body, let's get some more music going there. On the body, and then these need to be obviously more, yeah, right to the center. So I bet you if we went like this, and let's see here. That's going to be on top, yeah. Huh, this might be a little different. It's actually going to have to be out 2. Alright, now these are going to be just the body thrusters. So we'll make a panel for those. Actually, I'd like that to be up top. And these are just going to be a push button. Let's see. South. I guess it doesn't matter. Let's say west. East and then north. There, that makes more sense. All right, so we'll do that. And then we need, is this one empty? Is this one empty? Body thruster in. All right. All right. Composite. 1, 2, 3, and 4. All right, and then we need 4 outputs. 1, 2, 3, 4. Output. South. East. West. All right, and then north, south, west, and then east. Because the layout on the panel kind of makes sense. All right. So if we can update that. Now the orientation doesn't really matter because in space we just fire one. Or I'll just fire one button and then I'll know, okay, that's the direction. Because right now, what we're having trouble with is the linear speed. It was the Z linear speed. So we were actually going this way. Yeah. Yeah, we were going this way. So according to where the seat is, this would be the west one. And this would be the east one. And this would be the south. And now we're okay because these are in theory, close to the center of the ship. So if I blast these at full speed, the ship isn't going to start to spin. And that's sort of what is happening with these body rockets. I think that was out further than those ones there. So we're kind of doing this. So we're still going to need the body rockets, but we're also going to need these other rockets here. And then we may as well get a keypad so we can adjust the thruster strength. So now I know we could, somebody was asking me too about why not using the gimbal, the direction on here, gimbal Z and gimbal X. I just don't know, like, you know, like this is the orientation of it. And I just would have to take one rocket to space and then sort of move it around. And you know what I mean? I have to test it. I just haven't done that yet. And then once I've done that, I'll know. It was the same with the RCS. Just knowing which way it thrusts and which way it's, you know, X, Y, and Z. Because look, I thought I had everything going, and then I installed the pilot seat backwards. So that messed up. That messed up the entire rocket ship, right? And now look at how many rockets I've got on this thing. So that's kind of why I try not to use I try to be more like, you know, direct kind of, yeah. More rigid. I know I should be more flexible, right? I will. In the next one, we'll try and be a little more flexible in how we maneuver around, right? But, you know, for me, this is just kind of how I'm doing it. Haphazardly until it's built, then we can, then we'll look at it. Okay, so then we need, what's our systems? Which is this? It's just the systems button is just a backlight. And then here we'll have space is 0.03, and then space is 0.05, and then the body thrusters 0.03 seem to be enough. And then what I'll have to do is I'll have to pulse manually. This to slow it down, this to slow it down, that to slow it down, just to see kind of, do we even need these body ones, you know? And if we do, then do I need to maybe extend them? Maybe I should extend them so they're the same length as that one down there. Maybe that's the problem, right? Because in space, yeah, I'm theorizing here, I don't really know, but it's all about equal pressure. If we want to go one way, we want to make sure that we have equal pressure to go that way. Otherwise, if the pressure isn't equal, it's going to cause us to go on an angle. And I suspect that that's what was happening. Because the pressure right now, it's on an angle. So when we apply that force, it's going to apply that force on an angle, and it's going to cause us to do that. Again, I'm just theorizing. I don't, you know, but I've never been to space. I've never done these things in zero gravity. So for what it's worth, I did sleep in a Holiday Inn Express last night, so if that's worth anything, if any of you are old enough to remember those commercials. Oh boy! Right, so you see there, I'm not in alignment, so I have to cut that and go backwards. That one is not in alignment, so we have to cut that one. Or is it? Wait a minute. Yeah, no, it's got to be like that. Yeah, you see what I mean? The forces need to be equalized. Otherwise, we're going to be thrusting ourselves onto an angle, and that's part of the challenge when we're building. Is we have to test it to know. But we're getting close. We are getting close to unlocking the secrets of space in Stormworks. Alright, I will merge these after. I want to get the pipe work done. We still have one more rocket to move, and then we have to find a way to make it look like it's connected to this starship. I can't move the bottom ones over, or can I? Oh no, that's in the way. Yeah, we can't move the bottom ones in, so we have to move the top ones out. Unfortunately, that is the way. Alright, merge. Otherwise they'll fall off when we're launching, and we don't want that because we really need these in space. We don't actually need them on the planet. Now, the ones that I added were it's like, all right, let's look at the pipework to see which one's messed up more. They're both just so messed up. What's that? What's that one there? That's the nose. Okay, so it's the lower one that I gotta move out. It's going to go back by 2. There we go. So now it's kind of, I know it's kind of messing up the look of our rocket, but it is what it is. It's what it is. Alright. Now we got some pipe work to do. Alright. Alright. I guess we could turn that into a pipe. Yeah, we can do that. Just kind of make it look a little, give it some thickness. Right, so now when we apply force to the body, it's going to be equal force, and it shouldn't give us that awkward linear speed that we were getting while we were in space. And to me, it makes sense. Now it totally makes sense why we weren't slowing down at all with that awkward linear speed. There, we'll do that. That way it looks like it's attached. It totally doesn't look like it was an afterthought. It totally looks like we knew when we designed the rocket. It was totally part of it. Totally not an afterthought. Okay, so now that we have, yeah, see, now you see what I mean? So now we should have that equal linear force. The last thing I did want to check on was there are 2 buttons that seem to be connected to the same output, and that's, it's like north and south. Is it this one here that controls that? Oh. Yeah, see, this was our height, but I deleted all of the calculations for it, so that's why it doesn't work. That's why it doesn't work, but that's okay. We found a speed that does work. Okay, that would be our height here. We found a speed that does work. So, were these the nose? This is the body, right? North, south, east, and west. Yeah, this is the body that we reconnected. Okay, so this microcontroller is just a blank something for now. This one here, however, did I move? Really? I can't. How come I can't zoom out? Uh-oh. See, that's way over there. Uh-oh. Uh-oh. Alright, well, this obviously doesn't matter. It's the seat. Where does the seat come into? The seat comes into here. So this is our seat. that's why. But isn't that the and? Yeah. So this has to be activated and this has to be activated. So that shouldn't matter. North, south, west, and east. Alright, that might be it. That was kind of the last thing, and then we're ready. We're ready to go back to space, which will be in the next video. In the next video, we will launch to space again. And now it looks kind of weird. It's starting to look a little weird. That's alright. When it's bigger and it has a little spaceship on it and all that sort of stuff, that's when all this is really going to count. Okay, so we turn on the seat nose control. Yeah, that's exactly what it was. And then if we turn on the nose stabilizer, perfect. Perfect. There we go. Everything is calibrated. Yes, everything is calibrated. We should have equal thrusting. Now, again, what we want to work on is I'm going to do a little bit of inside spaceship work, survival systems, whatever. I'll think about that. We need a CO2 scrubber. It'd be nice to have one room. Maybe I'll make these like actual windows so we can look out. It'd be nice to have one room where we can just do that. We need a kitchen. We need a few more things. So like this rocket is not really set up for that, right? Spacewalking. It has room for spacewalking, and it just has a tiny little room. You know, one person, maybe two people maximum. But we can't stay in space for long. Unless we squeeze like a little, we'd have to squeeze a bed and a shower and everything into this little area here. And then the equipment onto this side. So I'm not too sure how that's going to look, but I'll have to think about it, conceptualize it, and then put it on there. Yeah, so anyways, thank you so much for watching, liking, and subscribing. That's going to do it for this video. We tested the systems. Now we know what we need to do. We need equal forces, and we're ready to launch again. So thank you so much, and I'll see you all in the next one.